All right, so let's take a look at it. We got the first exam, Math 122, fall 2024. First thing I would do is, look at this first page, by the way. And last name, I'll put my name down, Bannon. Whoops. Well, my first name is Ron. And my email address is bannon@essex.edu. You could also put your phone number down, 973-877-1886. All right? So honor code, basically, it says that you're going to do this exam on your own, by the way. That means you're not using notes, your cell phones, a calculator, and you're not looking at your neighbor's paper, by the way. So I'm just going to sign off on that and then start the exam. And the way I would look at the exam, by the way, is, certainly I'd read the question and I'd see if I want to do it. Now, if there's for me, by the way, I'd look at all 7 questions first. I would do that. But I'm looking at number 1. I'm saying number 1 looks pretty easy, and certainly you might say I've done it differently than you. But for the most part, it's a fairly straightforward question, by the way. And what I would do is look at this thing and say, I'm going to certainly try to tackle this problem, by the way. And the first thing I would do, I would probably say UE is equal to X, which forces me to say that the dV would be equal to sine 3 minus X dx, right? There's not going to be much work on the exams, by the way. So what do you get? Du would be equal to dx. That's pretty simple. Now this one might be more challenging for you, but it's the antiderivative of that thing over there, and the antiderivative of this thing is going to be, what would differentiate that? Differentiate to that would be a minus cosine. Now before you say that's the answer, by the way, you have to start to realize you differentiate, though, what you get? You would get sine 3 minus x times minus 1. So I got to change this. All right, let me go through that again, by the way. To differentiate that, I'm going to get the minus sine 3 minus x, and then minus 1, I'm getting back what I wanted to get, all right? So I'm going to say I can definitely write down integration by parts now. So I'm going to remind you what that looks like. That looks like u dv equals uv minus v du, all right? So let's see if we can do that. So my u is x, and my v is going to be cosine 3 minus x. And then I put minus sign down, my integration. The v, what's the v going to be? Well, it's cosine 3 minus x. And then I put down the du, which is just dx over here. Now, I'm going to say this is probably the first milestone in grading it. Were you able to do the integration by parts, by the way? And I'm going to say yes. It's not a difficult one, any tricks or anything. But I got x cosine 3 minus x, and then it's going to be minus something. And I'm wondering, what differentiates cosine? That would be sine. And that's going to be 3 minus x. All right? But then I realized if I were to do that, differentiate that, what would I get? I would get, minus cosine 3 minus x times minus 1, and that's a problem for me. So I'll put the plus sign down, and then plus c. I'm going to say it's my antiderivative at this point. Now, I'm a little retentive. What I'm going to do is I'm going to check it. And someone says, how do you check these things? Just differentiate. So let's just differentiate. I'm going to differentiate. I'm going to check it, and it's going to be x, because I'm wondering, did I get this one right? And that's what's nice about this class, that most times you can determine if you're right or wrong, by the way, just by simply knowing some simple facts, by the way. Well, let's differentiate. Differentiate in the first term. I'm going to say x, and that's going to be times the derivative of cosine, which is minus sine, 3 minus x, and derivative of the inside is going to be minus 1. Wow, this looks tough, doesn't it? Plus, the derivative of x is just going to be 1, cosine 3 minus x. I just did this thing. Let's do the next one, plus the cosine 3 minus x times minus 1. And derivative of c is just 0, by the way. And what does this give me? Let's put this down for you. It's going to be x sine 3 minus x. That's this thing right over here, by the way. Then I get cosine 3 minus x minus cosine 3 minus x. I'm just checking, by the way. These things cancel off. And I got to make sure that's the integrand. And it is. The integrand is x times the sine of 3 minus x. That problem is done. Now, by the way, in the blue area is the way I would type that up, by the way. All right? So let's go to the next question. And the next question is use shell method or the disk method. So it's basically saying that you need to do those methods that we described in class, by the way. So if I were doing the problem, the first thing I would do in the problem, believe it or not, is just draw the picture of it. And I don't see it as being a terribly difficult picture. And the first thing I see is I see an x squared, it's a parabola, and this is a root function. And I'm seeing that looks sort of like this over here. That's my parabola. And this is my root function over here. And I'm certainly, I know the points of intersection. This is the region. I will read that to you, by the way. So it says the volume is solid obtained by rotating the region. I got the region down. This point over here is 1, 1, and this point over here is 0, 0, all right? So the solid obtained by rotating the region enclosed by the graphs indicated about the y-axis over here. Now, granted, someone says, what method would you choose over here? It's entirely up to you what you want to use, by the way. But I'm going to say, a couple of different things on this one over here. You could use either the shell method or the disk method. So I'm going to say that when I'm looking at it, the first thing I would say is I probably would use the shell method on this, but I realize I don't want to do the shell method. But let me go through that with you. All right, so I'm going to do the shell method. And looking at it, I'm going to say the first thing I would do is a differential. And if it's a shell method, the differential is dx. All right, I'm using a shell method. And what do I do over here? I would, kind of look at this thing over here, and I realize the differential is dx. And I'm going to do that radius thing now because the circumference of this thing is going to be 2 pi times r. And the r would just be the x value over here, whatever that is, by the way. And then what I do the height of the shell. All right. Oh, by the way, I forgot to put the limits of integration down, 0 to 1. All right. What's the height of that shell? The upper minus the lower. Well, the upper is actually the root function, which is, x to the 1/2. And the lower is the quadratic, which is x squared. All right. So it's going to be x to the 1/2 minus x squared. And this is the shell method, by the way. So I'm going to do that. And the way I'm going to do that is just, get the number on the outside. And that's going to be 2 pi. That's going to be 0 to 1. X times x to the 1/2, that's going to be x to the 3/2. Minus, that would be x cubed, and then get a dx over here. So relatively speaking, that doesn't look too bad. I'm sure I did that right, by the way. Just my addition. Yeah, I think I can do the antiderivative now. 2 pi. And again, we're trying to write problems that are reasonable for you to do, by the way. We add 1 to the exponent. And if you add 1 to that, you'd get, 2 halves, which would be 5 halves. You're going to divide by 5 halves or multiply by 2/5. Minus, well, you're going to increase that by 1. That would be 4. And divide by 4. And the limits of integration go from 0 to 1. And what do you get over there? You get 2 pi. And then you put the 1 in there, you get 2/5. And again, we don't take arithmetic beyond grade school. And then the 1 there would be 1/4. All right? The 0 is nice, by the way, because it evaluates to 0 on both terms, by the way. If you want to write that down, just say I'm taking away 0 from that. And what does that give you? It gives you 2 pi. And then common denominator there, 5 times 4 is 20. And then you're going to get 8 minus 5. And what does that give you? 2 pi times 8 minus 5, 3 over 20. I'd reduce that. That's going to be 3 pi over 10. All right? And they're going to be cubic units, but you don't have to write that down by us. So 3 pi over 10. Now, if you want to do another method, that's fine, by the way. But the bottom line, no matter what method you choose, by the way, you're going to get the number 3 pi over 10. So I'm going to say what I believe to be a reasonable question with number 2. I'm going to go to number 3 now. And remember, you're only doing 5 of these things. And I'm kind of getting my favorite one, by the way. And I'll tell you why. Partial fraction is really kind of a simplistic problem if you can do the partial fraction by the way. If you can't, it's not so easy. But the first thing I would do is just the partial fractions. And I write this over here. I'd factor the denominator. It looks relatively easy to do, by the way. And I'm glad for that because I like those finger numbers. I want to check this, though. And what am I doing? X squared. That looks good. Minus 3 minus 6 is minus 9 and plus 18. So it's going to be A over x minus 6 plus b over x minus 3. I'd clear the fraction by multiplying both sides by the LCD, and you get 1 equals a times x minus 3 plus b times x minus 6. I would probably choose x to be 3 first, and what would you get over there? You would get 1 equals minus 3b. So I know the b now is minus 1/3. I probably would cross this out and put down minus 1/3 now, all right? I would also probably set x to be 6, because I think it's easy to do. You're going to get 1 equals 3a, and again, the b term would disappear, so a is just 1/3. So I'm going to cross this out, put 1/3 down. Now granted, someone says, what are you going to do now? I'm going to do the integration. And when I'm about the integration, it looks fairly simple to do, by the way. So I'll write the integration down. I'm going to factor out 1/3. And this is something I always do with my integrations, something I forget though. That's going to be 1 over x minus 6 minus, I'm doing that second term by the way, 1 over x minus 3, and that's a dx over here. Are these integrals easy to do? I'm sorry, the integrands easy to do? Of course they are. It's 1/3 natural log, absolute value, x minus 6, minus 1/3 natural log, x minus 3, plus some constant of integration. I'll put this over here. That's a fine answer. However, I want to point out you could also bring these together into one term if you wanted to, and that's written over here. But don't feel obligated to do so, by the way. But again, if you did that, you'd get what's written over here. All right, that's number 3. I'm going to say relatively simple question, and I kind of like simpler questions, especially on exams, by the way. This one over here, and again, I hope you start to realize that every question I'm giving you, you've seen before, if you're doing what you've been told to do, which is basically, come to the show and tell in class, and do what we ask you to do, the supplementary exercises and the web assigns, all right? So looking at this thing over here, it says find the area of the shaded region. Well, you know what, they're giving me the shaded region. I would like to know the points of intersection, by the way. I'm kind of looking at it, and I'm sort of like trusting of this thing over here, but I'm still going to verify. I'm saying this looks about 2, and this looks about 10 to me, just looking at it. But I could be wrong. I'm saying 100% right about these things, just looking at it. Looks like minus 2, and then that's much more difficult. I couldn't read that off the thing, because when I'm looking at that, I'm really not quite clear with it. But you know what? I want to just see if that's true, by the way. So I'm going to put this over here, and I'm going to put the y down, and the y would be, let's see, 2 cubed, right? You see what I'm doing? I'm using this over here. That would be 8 minus, 2 times 4 is 8 plus 10. That seems reasonable, but I want to check it over here too, by the way. Let's write that down for you. What would that be? 2. I'm going to plug that in, and what would you get? Y equals, that would be 12 plus 8 minus 10, and that's also 10. So I'm pretty comfortable with that. Let me just do this one over here, by the way. Let me do that, and certainly on this side up here, I'm going to write down minus 2, and I'm wondering what that y is, by the way. Now you must say this is important. Not really, but let's go through it. What do you get there? Minus 8. Then you're going to get minus 8, and then you're going to get plus 10. All right, what does that give you? That gives you minus 6. All right, put this over here. By the way, seems to be, it stands to read. I'm looking at it, minus 6, by the way. Let's just check that out over here, by the way. Minus 2, and let's see what happens over here. What do you get? Y equals, we're going to get 12, because, minus 2 squared is 4. And then you get minus 8 minus 10, which, again, looks like that is, 12 minus 18, which is minus 6. Looks pretty good, by the way. Now, someone says you waste a lot of time doing that. Not really. I'm kind of entertained by that. But what I want to do is I want to do the area of this thing over here. That's their question. The first thing I do is I do my representative rectangle, and then I write the integration down. And what's the integration going to be? It's going to be the differentials dx. What are my x values? I'm going from minus 2 up to 2. I'll write that down. And what's the height of that thing? It's the upper curve minus the lower curve. I'm hoping you're able to differentiate between what curve is what curve, but the cubic curve is the top one. I'll write that down for you. That's going to be x cubed minus 2x squared plus 10. That's the upper curve minus the lower curve. That's minus 3x squared minus 4x plus 10. All right? Now, someone says, is that enough to do? I guess it's enough to do, but what I got to do now is I got to, figure out what the integral looks like, and it doesn't look that bad to me. So I'll write this as minus 2 to 2. I do see x cubed. Minus 2x squared minus 3x squared is minus 5x squared. And again, we're trying to use numbers that are fairly simple, by the way. And let's just take a look at that. You know what? I think I made a mistake in copy. That's an X over here. I don't know if that was just my pen not working right. But let's see, I got minus 4x. And then 10 and 10 is 20. And that's dx. And again, we're expecting to do the integration, by the way. It's really, polynomials couldn't get any easier than that. You may not like the numbers. And I understand sometimes it's beyond my ability. But they're not bad numbers. This is going to be 4. That's going to be a 4. Minus 5x cubed over 3. This will be minus 4x squared over 2. and then you get 20x. Limits of integration going from minus 2 to 2. I want to do the evaluation, but again, if you feel like you can't do arithmetic, you probably shouldn't be spending a half hour doing something that's, grade school level arithmetic. So I'm gonna do it, but I could make a mistake. I'm not saying I don't make mistakes. So if I put a 2 over here, 2 to the 4th power, 2 times 2 is 4, 8, 16, and 16 divided by 4, right? I'm doing this one over here. 16 divided by 4 is 4. All right, let's do the next one. Minus, 2 cubed is 8, and 5 times 8 is 40. That's 40 thirds. Minus, I'm still doing the 2, by the way. 2 squared is 4. 4 times 4 is 16. And then I get 40. All right? Minus, let's do the lower limit, and I will do the arithmetic. That's going to give me, let's see, minus 2 to the 4th power is 16 over 4. Well, that's pretty simple. That's 4. Let's see, it's going to be plus now. And what's going to be plus 40 thirds? Again, I'm doing the minus 2 now. All right? Then what do you get? You can get minus 16 over 2, and then you get minus 40. All right? Again, I hope it's not beyond your pay grade to do that, and I'm going to, kind of look through that. And as I look at this, I want, kind of do some simple things. I get 4, that's minus 8. That's minus 4, and 40 is 36. Let me see if I did that right. 4 minus 8 is minus 4, plus 40 is 36. Minus 40 thirds, minus, let's do this one over here. I got 4. I got minus 8. That's minus 4. I got minus 44. And then I get plus 40 thirds. I'm going to do my arithmetic. And what am I seeing? 36 minus a minus 44. Let's see, that's 50, 80. All right? Minus 40, these are thirds, by the way, is minus 80 thirds. I'm going to do that arithmetic. Let's come down to 3. That would be 240 minus 80, which is 160. Final answer, all right? Again, if you found that difficult, I wouldn't do that question, by the way, right? You get choices here. So I'm going to do this one over here, and this one looks like, what do you do about this one over here? There's a variety of things you could do, by the way. But I'm kind of looking at it, and I'm going to say to myself, is trying to reduce the power of that cosine would be probably a pretty good thing to do, by the way. Now, what I'm going to claim over here is I want to reduce the power, and there's a reason for that. That powers are pretty difficult to deal with, by the way. And I'm going to say I'm going to borrow a cosine squared from that. So I'd have cosine 3x times cosine squared 3x dx. The next thing I would do is I'd write that cosine squared in terms of sines. So let me put that down for you. 0 to pi over 2. And it's going to be cosine 3x times, and the cosine squared would be 1 minus sine squared. The next thing I would do is I'd do a u substitution. And I would say u is equal to the sine of 3x. Now what I like to do is, so definite integrals is just, completely go there, by the way. So I want to point out the first thing I'm looking at is 0. Right now, if x is 0, by the way, what would u be? It would be the sine of 0, which is 0. Relatively simple. The next thing is pi over 2, and what I get is the sine of 3 pi over 2, which is actually also pretty simple, just minus 1. All right? So I'm going to claim that's done. All right, I got those. Now, the next thing I want to do is I just want to put this down over here. And that's going to be 1 minus u squared. I've got trouble over here. I got this thing to worry about. And I need the differential now. So what's du going to be? It's going to be the cosine of 3x times 3 dx. So the du is going to be 1/3. Let me put this over here. I'm going to side, by the way. So it's going to be 1/3 of a du would be the same thing as cosine 3x dx. So I got that now. What's that going to be? 1/3 of a du, right? So things are working out pretty nice. I'm going to put this down now. So it's 1/3. Antiderivative of 1 would be u, and then I'm going to get minus u cubed over 3. The limits of integration go from 0 to minus 1. Again, I consider this grade school arithmetic, but I'm not the first guy that's going to claim that I've never made a mistake, by the way, but You can make a mistake in this over here. Let's hope you don't make a mistake. So minus 1, and then what are you going to get? You get plus 1/3. All right? So I just evaluate the minus 1, and I get minus 1. And if cubed minus 1, you get minus 1. So minus 1 is plus 1, so 1/3. What does this give me? 1/3. Oops. And then minus 1 plus 1/3 is minus 2/3. And that's going to give you minus 2/9. All right, that one's done. And we're on problem number 5. All right, let's go to number 6. Number 6 is what I told you in class, that we were going to give you something that comes from Calc 1. And this is about, can you differentiate, and do you understand what derivatives give you? And the first thing is, the critical point. So the first thing I do is the demand of the problem. And the demand of the problem is all real numbers except for 0. So I'm going to say minus infinity up to 0, union 0 up to infinity. So the critical number's got to be from that set of numbers, by the way. So what do? I take this derivative to get the critical numbers. Fairly easy to do. What do you get? Minus 2x, right? I'm pulling the minus 2 down, minus 3. And then it's going to be plus 3x to the minus 4. Now again, I got to rewrite this guy because it looks strange to me. It's minus 2 over x cubed plus 3 over x4. I'm going to get a common denominator of x4. And what do you get over there? 3 minus 2x. So critical numbers are where it's undefined. Now granted, you may say it's undefined at 0, but this is not in the demand of the problem, so I can't use 0. So the only critical number I got is the top ever equal to 0. And it is. When is it equal to 0? When 3 equals 2x, or when x equals 3 over 2. So the critical number, there's only one, is this thing over here. Now granted, if you look at this over here, I certainly put the answer down for you, but I also graph it out for you, and certainly the critical number, they didn't ask you to do this over here, is where a maximum would occur. And that's a local maximum right over here, by the way. All right? That was a simple problem, but again, if you're looking at it, I don't remember critical numbers, don't do that problem, Ben. All right, let's do number 7. That's the last one over here. Number 1 says use the indicated substitution. And the reason I give you these things over here, because I realize a lot of students, they say, it's so much to remember, I can't remember what the substitution be. So I gave you what the substitution is, by the way. However, you may say, I'm going to do it differently, and I would probably say that's a mistake to try to do things differently. We're trying to give you nice, simple hints, by the way. So I'm going to use substitution, by the way. And to do that, the first thing I'd like to write down is dx. And what's dx going to be? 3 cosine theta d theta, right? So what I want to do is I want to, basically, leave the land of x and go to the land of thetas. And this might seem difficult, but I want to do it. I'm going to do this over here, by the way, put equal down. And the first thing I'll do is I'm going to discuss, if the substitution, and this is x is 0, by the way, if I write this down over here, I get 0 equals 3 sine of theta. And again, I always talk about the invertible region, by the way. And the invertible region of sine function is between, minus pi over 2. Minus pi over 2 and pi. But I look at this thing, and when is the sine equal? The sine of theta equal to 0? And 3, no bearing on the matter. That's 0, by the way. What's the next one going to be? I'll write this one down. So it's going to be 3 halves now. So I'll write this over here. 3 halves equals 3 sine theta. Divide both sides by 3, you get 1 half equals sine theta. Then the big question is, when does the sine of theta equal 1 half? And I hope you realize these are pretty simple problems over here. I'm going to put this over here as a triangle for you. 1, that would be 2, and this would be root 3 over here. All right, what am I using? The basic things you learn in trigonometry, some really simple triangles over here. And that's actually 30 degrees, but I can't really speak in degrees because it makes no sense, by the way. So I'm going to say, what is that in terms of radians? Pi over 6. And now I'm going to make my substitutions. I'm hoping things work out really nicely for you. What's x squared? I'm looking at it, and that would be this thing squared, which would be 9 sine squared theta. Relatively simple. I'm going to look at the bottom. I'll write this one down for you. It's the root, and that's going to be 9 minus 9 sine squared theta. And I got to put this thing down now. And why is that? I need to dx down. What's that going to be? 3 cosine theta d theta. All right, someone says this looks awful, by the way, and it certainly looks much worse than what I had. But the bottom line is, if you do a little bit of simplification, it's going to work out really nicely. All right, let's put this down. I'm going to do the number first. I see a 9. I see a 3. That's 27. I'm going to factor a 9 out from this over here, which would be root 3. So I definitely get a 9. And put this over here. All right? Let me see what I got now then. All right? Let's put this over here. 0 pi over 6. I'm going to be real careful with this. It's sine squared theta cosine theta. I already got the numbers done, by the way. D theta. And on bottom, I get the square root of 1 minus sine squared theta, which is the cosine squared theta. And on the invertible region between, minus pi over 2 and pi over 2, the cosine theta, I don't have to worry about the, division by zeros, by the way. So I'm going to say over here, it's going to be cosine of theta. All right? Not so bad, by the way. And someone says, why is it not so bad? I'm seeing a nice cancellation over here. And I'm seeing this is 9, and then I get 0 pi over 6 sine squared theta d theta. Now, I realize I'm stuck now. I don't know what to do about this. I don't know the answer to sine squared. Some people write the wrong thing down, and that sort of like kills them at this problem over here. But there is some things you get credit for at this point. I mean, you followed my instruction and got to this thing over here. Good for you, by the way. But what I want to do is I want to remind you that this has something to do with double angle formulas, and it's a cosine of 2 theta. And a cosine of 2 theta, there's 3 different ways you can write that down. One way you can write down is 1 minus 2 sine squared theta. All right? So this can get manipulated to 2 sine squared theta equals 1 minus cosine 2 theta. And you divide by 2, you get sine squared theta would be 1 minus cosine 2 theta over 2. So the point of that is we're reducing the degree. I'm going to pull a 2 out. I'm going to get 9 over 2. This goes from 0 to pi over 6. And then what do I get? I get 1 minus cosine of 2 theta d theta. Can I integrate that guy? I can. And what do you get? 9 over 2. The antiderivative of 1 is going to be theta. The antiderivative of cosine is going to be the sine 2 theta. I got to worry about that 2 because when I differentiate that, a 2 is going to pop in there. I want it to cancel off. And then what do you get? You get 0 and you get pi over 6. Now granted, we do expect you to do the arithmetic on it. Again, if you don't know your trigonometry, you want to review that. But let me write this one down for you. You can get 9 over 2. You can get pi over 6 minus, I want to point out, if you multiply pi over 6 by 2, you get pi over 3, which is 60 degrees, by the way. I'll write this over here. And what 60 degrees look like? Let's see, this would be 2, this would be root 3, and that would be 1. And what's the sign of that going to be? Root 3 over 2 divided by 2. We'll take care of that later, by the way. Minus 9 over 2. Put the 0 in there, you get 0. And what's the sign of 0? It's 0. Wow, that's convenient because this thing disappears. What are you left off with? Not too bad, by the way. All right. Now, when I say not too bad, I want to go through the steps for you. But again, if this is your answer, it's fine. I'm not going to disagree with that. So let me just put this over here. I'm going to say 6. This would be pi. And what do you get over here? You know what? I'm going to, let me get my eraser out. I noticed that there was something that I probably should have simplified before going forward. Let me get this eraser out. Get the eraser bigger. Go back this over here. So 9 halves, pi over 6, minus, this is going to be root 3 over 4. All right? How'd I do that? Multiply top and bottom by 2. Let me just go through that with you. 9 halves. And that's going to be 12 now. And you can get 2 pi. And what do you get over here? Let's see. You're going to get 3. All right. Whoops, sorry about that. All right. I'm looking at this. I want to reduce it. It's just my tendency to do things. I'm going to do it by 3. That's not so bad, right? This becomes 4. And what do you get over here? Let's take a look at that. You get 8. And you get 6 pi minus 9 root 3. All right? By the way, certainly I typed this up, make it a little bit easier for people to look at. I want to see what I wrote down for the answer over here and see how we're doing over here. I noticed that they wrote a little bit differently, and I'm saying, is it really the same thing, by the way? I'm always worried about that. What do you get? I'm going to say, I got the 8 in the bottom, and that's 6 pi, and that's 9. So things work out pretty nicely, by the way. And that's the end of the exam, by the way. So remember, you pick 5. Hopefully you pick the 5 that you can do quickly. Are some more difficult than others? That's a personal preference, by the way. I think they were all reasonable questions, but again, you could bring it to my attention and say, I don't think anything's reasonable, and that's fine by me. You should probably discuss these things with your teachers, by the way. So anyway, we're done. Thank you for paying attention.